Good morning, class. Today we're going to talk about solving one-step equations. But before we get into solving one-step equations, I want to reinforce what we learned yesterday. Remember yesterday we talked about real numbers and how to solve real numbers? This is an example of a problem that involves real numbers. So in this case, we have 5 plus -3, which we can also rewrite this as 5 minus 3. There's multiple ways of solving this. In this case, we can use our fingers, right? We have 5 fingers in one hand. And let's say, God forbid, we take away 3 fingers, right? How many fingers do we have left? We have 2 fingers, and we need to show that. We still have 2 fingers left. Or we can use our cubes, right? Remember that cubes, the blue ones, means they're positive. So we have 5 positive cubes. And from those 5 positive cubes, we're taking away 3. And remember that here we have how many pairs? We have 3 pairs in this case. And we only write our leftovers. In this case, how many leftovers do we have? We have 2. So our answer is 2 in this case. Another example. Let me write another example. Say we have -5 plus 3. Right? So in this case, remember I told you guys that negative signs means that you owe, plus is that you paid. There's different ways to solve this one as well. So let me use this method. So let's say one day we owe Louis, right? We owe him $5. And the next day we pay him $3. Do we owe him something? Yes. How much do we owe him? We owe him $2. So our result is going to be 2, right? But we need to show that we owe Louis $2. And to show that we owe him $2, we need to write the minus sign. In this case, we put minus here. Or you guys want to see the cubes, use the cubes. Remember the red ones mean minus. We got 5 red cubes. And we're adding to those red cubes 3. So how many groups do we have? We have 1 pair, 2 pair, and 3 pairs. Then we write our leftovers, right? Here, how many leftovers do we have? We have 2 red cubes. And red cubes means that they're negative, they're being subtracted, so we need to show these 2 negative numbers. It's a negative number. 2 is a negative number in this case. Another example is having -5 plus -3. We can rewrite this as -5 minus 3 because whenever you multiply a negative and a positive, it becomes negative. So here, one day we owe Louis -5. The next day we owe him $3. How much do we owe him in total? In this case, we owe him $8. And to show that we owe, we have to put the negative sign. Don't forget that. Or we could use the cubes to illustrate this problem. So you have 4, 5. Then we're adding 3 more negative numbers. Remember the red cubes mean negative. Now here, even though we see that there's 3 pairs, but we cannot eliminate them because they're not opposite numbers. We can only eliminate if they were opposite numbers, like in this case we have this 2. But since we don't have opposite numbers, we cannot eliminate. So in this case, we need to add how many cubes we have. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 cubes. And we know that red means negative. We're subtracting, so we need to show that we're subtracting. In this case, we put the minus number here. Another example, which this one is the easiest one. I don't think anyone had any problems when I checked your essay tickets. Now here we have 5, right? We can use the fingers again. And we're adding 3 more. So how many fingers do we have? We have 8 in total. Now let's look at some examples, right? So remember the rule. We have to perform the opposite operation. So if we have addition, we have to do subtraction. If we have subtraction, we have to do addition. If we have multiplication, we have to divide. And if we have a division, we have to multiply. So let's look at this example here, right? Remember, the equal sign separates the sides. Okay? So in this case, let's name this side A and this side B. Your first question is, which side is X? In this case, X is in side A, right? The next question, what is bothering A? X. What is bothering X? In this case, what's bothering X is that plus 3. So we have to get rid of plus 3, right? Because the rule is, our goal is to make sure that our variable, in this case is X, is by itself. Now you have to look at what is going on between X and that number. We have addition. Now what is the rule? What is the main rule to solving one-step equation? Is to perform the opposite. What is the opposite again of addition? Is subtraction, right? So we need to subtract from X that same number. We have to subtract from X, and what we do to one side, we have to do it to the other side. Now what is 3 minus 3? In this case, they cancel each other out and they become 0. So now I'm going to bring down what I didn't use. So we have X. This is 0, right? We don't have to write anything here. We bring down the equal sign. Equals, remember, we solved this before. So we have 5 minus 3. From 5, you're taking away 3, right? And that is 2. This is X by itself? Yes. Because X is by itself, we solve our one-step equation. Now we have to check if our answer is correct. How do we know if our answer is correct? It's by checking. So it's very important to check your answer. So in this case, we found that X equals to 3. We're going to use that to our advantage. Let me rewrite the equation. So we got X plus 3 equals to 5. Now we solved that X equals to 3. So here in this case, to check, we're going to replace X by 2. So it's no longer going to be X. It's now going to be 2 because we solved that X equals to 2. So now 2 plus 3 equals to 5. We need to check if this is true. So what is 2 plus 3? It's 5, right? So is 5 equals to 5? Yes. Because of the fact that this is true, our answer is correct. So now we know that our answer is correct. Let's look at another example. So let's look at another example. We have example number 2. So we have X minus 4 equals to negative 2. Okay? Remember, we have to separate the sides. In this case, we have 2 sides. So this is side A. This is side B. Now, we have to look at what side is X. X in this case, this is side A again. Then, you have to ask yourself, what is bothering X, right? Our goal is to leave X by itself. That is our goal. We want to leave X by itself. In this case, what is bothering X? That negative 4, right? So we see that between X and 4, there's subtraction. What is the opposite operation? Remember, that's our main rule. Opposite of subtraction is addition. So we're going to add that same number on both sides. So what you do to one side, you have to do to the other side. So here, we know that negative 4 and plus 4 equals to 0. So we're going to bring down what we didn't use. So we got X equals to negative 2 plus 2. We have X equals to negative 2 plus 4. What is that? 2. We have X equals to 2. Now we have to check. Let's check our answer. So we're going to rewrite the equation. And we solve that X equals to 2, right? So now we're going to plug in Instead of x, we're going to have 2. 2 minus 4, is that equal to negative 2? So here we have to solve our left side, right? So we have negative 2, is that equal to negative 2? Yes? Then our answer is correct. Let's look at another example. Let's look at another example, right? We have example number 3. So remember, we separate the two sides, right? We have side A and side B. Now x, again, is inside A. Now, what is going on between 2 and x? What operation is this? This is multiplication, right? So what is the rule here? We have to perform the opposite operation. So what's the opposite of multiplication? Division. So in this case, we have to divide by that exact number. What is 2 divided by 2? It's 1. So you have 1x equals 2. What is 4 divided by 2? In this case, 2. Note that 1x is equal to x. In mathematics, we turn that 1 into invisible 1. So here we solve that x equals to 2. Now we have to check our answer. So you rewrite, right? We got 2x equals to 4. We solve that x equals to 2. So we're going to replace the x by 2, right? Because that's what x equals to. Here, what is 2 times 2? Is 4. So 4, does that equal to 4? Yes? Then our answer is correct. Let's look at an example that has division in this case. This is our fourth example, right? Separates the sides. Now, let's look. What is going on between the x and the 3, right? Our goal is to leave x by itself. What's going on between x and 3? Division, right? And what's our rule? Whenever we have division, we have to use multiplication. So we have x over 3. We have to multiply that by that same number. Multiply both sides by that same number. So remember, we learned that whenever you have a whole number and it's being divided by itself, it becomes 1. So we have 1x again equals to 3 times 1. We will know that is what? 3, right? Remember, we can rewrite that as x equals to 3. We solve our answer. X is alone. So we solve our answer. Now we have to go check again. So we're going to plug in x. Let's rewrite our equation first. We solve that x equals to 3. So we're going to rewrite. We got 3 over 3. Does that equal to 1? What is 3 divided by 3? Is 1, right? So 1 equals to 1. And since they equal to each other, our answer is correct. Now I want you guys to use the blocks that I brought you guys. I'm going to show an example first. And then I want you guys to use it in your group work. So remember, blue cubes means addition, and red cubes means subtraction. So in this example, we have x plus 2 equals to 3, right? So we're going to write x here. Now we're going to add, since we have that blue cubes are addition, we're going to put 2 cubes, right? We're adding them. Equals to 3. Since this 3 is positive, right? We're going to use the 3 cubes here. Now remember the rule. Whenever we have addition, we have to do subtraction. In this case, we have what? Addition, right? So the x and 2 are being added. So we have to do the opposite operation in this case, which is subtraction, right? And I said that the red cubes are subtraction. So we're going to use the red cubes. And what we do to one side, we have to do to the other side, right? So we subtracting the 2, right? And we're going to do the same thing. We're subtracting 2 here, right? Remember that whenever we have 2 of opposite colors, they cancel each other out. In this case, I'm going to bring the x, right? They cancel each other out, right? So is equal to 0. So you don't have to write anything. Now here we have to look at how many cubes get canceled in this case. So here we see how this one and this one, they have opposite colors, and this one is the only one that is left that doesn't have a partner, you could say. So here we know that this cancels out. And how many cubes do we have left? 1, right? So x equals to 1. Now let's solve it algebraically, right? So we have x plus 2 equals to 3. Remember, we have to ask what's going on between x and 2, which is addition in this case. So we have to do the opposite. We have to subtract by 2. Now we have x equals to, what is 3 minus 2? 1. So we get the same answer, right? So you guys can use the cubes in your groups if you guys want, or you could solve it algebraically. I want you guys to check your answers, okay? I'm gonna go around and see how you guys solving the equations. I want to look at more examples. Now in this case, right, separate the sides. Now here, whenever we have 1 over 4, x is the same thing as saying x over 4. Why? Because we have 1 over 4 times x. To turn this x into a fraction, we have to divide. Remember, we learned yesterday that any number, to turn into a fraction, we divide it by 1. So we know that whenever we have 2 fractions, we have to multiply across. So we got 1 times x, remember we learned that, we got 1x, and then 4 times 1 is just 4. We can rewrite this as x equals to 4. So that is why we can rewrite this as x over 4. So then we just rewrite equations, right? So x over 4 equals to 2. Now, we know how to solve this, we just learned this, right? So here, what is going on between x and 4? It's what? Division, right? And the rule says that when we have division, we have to multiply, right? So we're going to multiply this whole thing by 4. We have to do what we do to one side, we have to do to the other side. So we know that this becomes 1x, which equals to 8. Because we write this as x equals to 8. Now we have to check our answer. Okay, we write our equation where we saw that x equals to 8. We're going to plug in 8 as x. What is 8 divided by 4? It's 2, right? So 2 equals to 2? Yes, so our answer is correct. Now I want you guys to try one. So you have 1 over 6x equals to 1. Remember, we can rewrite this as x over 6 equals to 1. So, like Kayla said, x and 6, they're being divided. So we have to use multiplication. So we're going to multiply this, both sides, by 6. And she said that this turned into 1x equals to 6. Which you can rewrite it as x equals to 6. Then she checked her answer. She wrote the problem and she plugged in x as 6. So she wrote 6 over 6 equals to 1. Then she found that 1 equals to 1 and she knew that her answer was correct. So tomorrow we're going to be talking about two-step equations. But there are some examples, some problems that can be considered one step or two steps. For example, let's say we have 3 over 4 x equals to 1. So I'm going to solve it using the one step. In this case, to do one step equation, let me rewrite the problem. We got 3 over 4x equals to 1. We have to use the reciprocal. So remember the reciprocal, we flipped the fractions. So we now have 4 over 3. And here we have 4 over 3. So we're multiplying the two fractions together so that we can get 1. So here, we know that here we get 1 over 1x. We get 1x, which equals to here. Remember, we turned that whole number into a fraction, and by doing so, we put over 1, 3 times 4 over 3. And then we get x equals 2, multiply across, right? So we get 4 over 3. So this is our answer. Now we have to check. Plug it in. So we got 3 over 4. Plug in 4 over 3. Does that equal to 1? Remember, this is the reciprocal of each other. So we know that that becomes 1 equals to 1. Since our answer is correct, then our solution is correct. Now this is 2 steps, which we will be learning tomorrow. How to solve 2 steps. We got 3 over 4, x equals to 1, right? Remember that whenever you have a fraction, you could just bring up the x. We have 3x over 4 equals to 1. To do those 2 steps in this case, we're going to pretend that 3 and x are one item. And then we're going to solve it like if 3x it was 1, it was x. So like say I'm going to replace 3x by x, right? In this case, 4x equals to 1. You have to look what is going on between x and 4, division, right? What was our rule about division? We have to use multiplication. The opposite was multiplication. So we're going to multiply both sides by 4, right? But remember, this x is not just x, it's 3x. I just replaced it by another, the same variable, using the same variable. So let me erase this. We have 3x. And we know 4 and 4, that becomes 1, right? So we have 3x equals to 4. Now here, is x by itself? No, right? What is going on between 3 and x? Multiplication. And remember, the opposite of multiplication is division. So in this case, we have to divide by 3. So we divide both sides by 3. And we get x equals to 4 over 3. That's the same answer that we got here? Yes. So both methods are correct. You could either use the 2 steps or the 1 step. They both are going to be correct. They're both going to give you the same answer.